Okay, so now we're going to the easiest part of taking derivatives, honestly. Okay, so we're going to talk about the power rule, this super important rule that we're going to use. Okay, so the function is going to be what you have here, x to the power of n. Okay, so what you're going to do is you are going to multiply the value of n times the coefficient, so you have that it's going to be n times x, and it's going to be n minus 1. Okay, that's going to be the rule for taking derivatives with polynomials. Okay, so pretty simple. You multiply this one here. Okay, you are going to see it in this example. Okay, so the first example, you have that f of x is equal to x cubed. Okay, so what are you going to do? You are going to take your 3, multiply it times the 1 that you have here in front, because remember you have a coefficient 1. X, 3 minus 1 is 2, and that's it. That's your derivative. Isn't that simple? Now you're going to tell me, well, this one is not as straightforward, right? But you know that the square root is equal to x to the power of 1/2, right? So that fixes it. Okay, so what do you have here? Your derivative is going to be equal to 1 over 2x, and 1/2 minus 1 is going to be negative 1/2. So you just need to be careful here and rearrange. Okay, so I know that this is going to be equal to 2 times the square root of x, okay, which is true. So that's what you have. Now here, you don't like it because it looks like a fraction. Don't worry, you know your exponent properties, right? So you know that this is true, okay, t to the power of negative 4. Therefore, when you take the derivative, what do you know? It's going to be negative 4t, and then to the power of negative 5. Why negative 5? Because it's negative 4 minus 1. Of course, you can rearrange so this looks better, and I would, okay, always, but that's true. Okay, now let's move on to this one. Okay, it seems pretty simple. Do you have an x? No. So what's going to be the derivative? It's going to be 0. Why? What is the slope of an horizontal line? What's going to be the tangent line? Well, so it's going to be 0. Okay, so that's why. Okay, so for this one, what are you going to do? You do 3 times 5 x, and then 3 minus 1, right? So you have that this is going to be equal to 15x squared. Okay, isn't that simple? So let's talk about this one a little bit more. The derivative of a constant rule. If c is a constant, then you know that the derivative with respect to x of that constant is going to be always 0. So this one could be 100, could be pi, could be e, could be tau, could be a value that it's going to be 0. Okay, so some properties of the derivatives that are going to sound quite obvious for you. If you see this notation, okay, what's the meaning of this? This is going to be the meaning of f prime of x plus g prime of x. Okay, don't overcomplicate things. Similarly, if you see this notation, what's going to be that? It's going to be f prime of x minus g prime of x. Nothing too scientific here. Okay, so let's move on and take the derivative of more situations. Okay, so what's going to be the derivative of this beautiful cubic polynomial that you have over there? Okay, so the derivative is going to be 3 times 4, which is going to be 12x to the power of 2, and then minus 10x plus 7, and this one is going to be 0. That's it. That's your derivative. Isn't that easy? Now, this one you're going to tell me, oh, it looks ugly. We haven't talked about, the quotient or ratios or things like that, right? But this one you can simplify it a little bit more. You can think about this like this, don't you? Okay, so with that you can simplify it, and you know that it's going to be 5x power 4 minus 3x power 3 plus, and the last one stays like that. Okay, that one is pretty easy to take the derivative. Why? You can take out the derivative of each one of the terms. Let's take the first term. It's going to be 20x to the power of 3. Okay, the second one is going to be negative 9, okay, x to the power of what? It's going to be x to the power of 2, Okay, and last but not least, you know that that one is going to be kind of like a negative 1. Okay, so it's going to be negative 4x to the power of negative 2, meaning that we can rewrite this, so I have all positive exponents, because that's what my pre-calc teachers told me to do, and they are completely right, and you have this. Okay? So if they ask you, determine the point at which the given function has an horizontal tangent line that we have over here. Let me move it over. What are you going to do? Okay, so the first thing that we are going to do, since they are talking about a tangent line, every time that they talk about a tangent line, take the derivative and you'll be close to the solution. Okay, so take the derivative is going to be 3x squared minus 12. Okay. After that, what are you going to do? They are telling you when it has an horizontal tangent line. Horizontal tangent line, it means that the slope is equal to 0. Okay, so what we're going to do is we're going to equalize that situation to 0, okay, and solve it. Okay, so what are you going to do? You solve it, so you have that 3x squared is equal to 12. You know that x squared is going to be equal to 4, meaning you have that x is going to be equal to plus minus 2. Okay, so you have two situations. Okay, first situation, for x equals 2, what do you have? F of 2 is going to be equal to 2 power 3 minus 12 times 2, okay, because I'm plugging it here at the original, is going to be equal to negative 16. Now, for x, when it's equal to negative 2, you have that f of negative 2 is going to be equal to negative 2 power 3 minus 12 times negative 2, and this is going to be equal to positive 16. Okay, so we have 2 points. Okay, so the function f has an horizontal tangent line. Okay, at the points the first one that you have, 2, negative 16 and negative 216, and that's it. Now let's talk about the derivative of your favorite, the trig functions. Let's start with sine and cosine. Okay, so we say that the derivative of the sine of x is going to be equal to cosine of x. Okay, and the derivative of the cosine of x is going to be negative sine of x. Okay, so you need to remember this too, because we're going to use them like non-stop from now on. Okay, so if you have a function that looks like this, what's going to be the derivative? You're like, okay, the first one is kind of like a polynomial, true, so it's going to be 12x. And the second one is going to be negative 5 sine of x. Okay? Why negative? Because you know that the derivative of the cosine is negative. So be careful with this negative. Okay? So the average rate of change of f on the interval ab, you know that it was f of b minus f of a divided by b minus a. Okay? We also talk about this as the average velocity. The instantaneous rate of change at f that when x equals c is f prime of c. Okay, which is the derivative evaluated at the point. Okay, FYI, in case that you forgot. Let's look at this example. F of x is equal to x cubed minus 3x squared plus 4. You need to find the average rate of change of f on the interval 1, 5. So what are you going to do? Don't complicate yourself. Average rate of change is equal to f of 5 minus f of 1 divided by what? 5 minus 1. Okay? So plug it in the equation that you have, right? So you have 5 cubed minus 3 times 5 squared plus 4. Okay? And then I'm going to put parentheses minus, and then you have that it's going to be 1 cubed minus 3, 1 squared plus 4. Okay? Close the parentheses, and you have that this is going to be divided by 4. Okay? Surprise, surprise, this is going to be equal to 52 divided by 4, which is 13. Okay, so this is going to be 13. Okay, average rate of change is going to be 13. Okay, now find the instantaneous rate of change at x equals 3. What are you going to do? The instantaneous is going to be prime. Okay, so what's f prime? You know that it's going to be 3x squared minus, and it's going to be 6x plus nothing. Okay, I don't know what I was trying to write there, but no. Okay, so you have the situation. Now, at 3, what are you going to do? You know that it's going to be 3, so plug the 3, so it's going to be 3 times 3 squared minus 6 times 3, which this will give you, surprise, surprise, what value is going to give you 27 minus 18, which is 9. Okay, so thus f prime of 3 is going to be equal to 9. The end. Okay,